Hello, so I'll be talking about TLD badges today, that is thermoluminescent dosimetry. Before going into depth of what are the parts of it, let us know what thermoluminescence is. Now, thermoluminescence, as the name says, on producing the heat, sorry, uh, on heating, there is light being produced, that the observed dose is being measured here, that is the dosimetry. Now the energy is the materials, the crystals that we usually use for this is lithium fluoride. This is the most common and the most important one. Other ones are lithium borate, calcium sulfate, and calcium fluoride as well. So this is the most common TL material that is being used. Now coming to the basic, what exactly happens in the TL material. So if an atom is is separate, or a molecule is separate, there are discrete energy levels. As they gain energy, they move to the upper shells. So what happens when it is in a lattice form, crystal lattice form? There are common energy bands. This is valence band and this is conduction band. Now electrons move freely in the valence band, and if they get energy, they move to the conduction band, and they can move freely in these valence and conduction band. But there is a forbidden energy gap. There is a forbidden energy gap in between conduction and the valence band. Now what exactly happens normally is, like when ionizing radiation falls on this, electrons are generally present in the valence band, like the outermost electrons, right? Now if they gain energy from the ionization, they move to the conduction band. So after some time, they are supposed to usually fall back to the valence band and release a photon in the form of a visible light. That is what you see. But what happens is, like, there is a trap system. So at room temperature this does not happen. So we add impurities into the lithium fluoride, that is magnesium. So that process of electrons being trapped usually does not happen just with lithium fluoride, or it is very less. That's why you add more impurities to it. Now what happens if you add more impurities? That is the doping procedure, right? So now impurities if you add, this is the forbidden band, now forbidden gap, right? So what happens is, it will create fake, like, intermediate energy levels here. So there will be some traps, TL traps, in the forbidden energy band. So after, like, when once, because of the radiation, the electrons which are in the conduction band get trapped. When it's coming down, it gets trapped into this gaps, into these holes. So this is called the TL trap, and here the electrons are in metastable state. Now they can't come back to the valence band until a heat is applied. So at room temperature, they are trapped in the forbidden band. Now if you increase the temperature, then the electrons come back to the valence band from the forbidden state, like from the forbidden to conduction, and then it falls back to the valence band. So this happens when you apply heat. So this is the basic procedure how it works. So if you take the TLD sample, so like TLD material, then you apply heat. So this is the power heat supply. Then the photons are being produced, the visible light. Then these visible lights are being amplified. So then these are being converted into the electrical energy. Now these is being measured, that is the recorder. That's how you measure the absorbed dose of it. Now again, this is the same one, just a little bit more clear. Valence band, conduction band, electron traps, and the TL photon being produced. Now this is called a glow curve. So I said about the intermediate levels, right, in the forbidden band. So there will be one particular intermediate level which is like the peak of it. So at lower temperatures, when you heat it a little bit, you will see some peaks of it, but these peaks are not so important because they are other intermediate levels, but the highest peak is the one, and the area under the curve, if you measure, is what you get as the number of photons being produced over there, the area under curve of the glow curve. This is called glow curve. Okay, now this is the same information, but if you see, this is at a temperature, lower temperature, you can see some small peak. This is the important peak, and this is the area that you measure. So this is the preheat phase, like when you are trying to measure the TLD after some time, how many electrons are trapped until now. Then this is the read phase, where you heat up to 300 degrees Celsius to know which of the electrons are being released as photons. This is the read phase. Then the annealing phase is they heat up to 400 degrees Celsius to remove everything which is there in the forbidden band. So all the electrons which are there in the forbidden band, that is called annealing phase. So electrons which go back to the valence band, and it can be reused again. So that's the process. Now what exactly are all of these? Just to know about it, so this is the metallic filter, this is the plastic filter, this is an open window. Okay, so open window, plastic, and metallic. So metallic has aluminum and copper, plastic is just perspex, open window. So metallic filter is like where the X-rays and gamma rays, it measures that. Plastic filter, beta rays, and the open window is for all type of radiation. Now it can be worn, it has to be worn outside the lead apron, and there are other sites also where it is kept. Now the most common thing we see is chest, right? On the chest it is usually kept. It is also kept near the neck, where thyroid is there, to measure how much the thyroid is getting. Also near the genital area. Also surgeons who are dealing with, they also have a form of ring TLD as well. This is called ring TLD. And some people who are dealing with radiopharmaceuticals, they have wrist TLD as well. Now these are the Teflon discs. These are the Teflon discs where it has the lithium fluoride with magnesium as the impurity. Okay, now this is covered with the information, and there are three filters. You can see, this is the metallic filter, this is the plastic perspex, and this is the open window. Now so see, you can see here, this is a copper color. You can actually make out this is copper plus aluminum, Al plus Cu. This is perspex, and this is open window, and these Teflon discs are sandwich between this and this, so it closes. So this one will be the window, and this will be the Teflon disc, and again a window. So these Teflon discs are sandwiched between these two parts of it. So that is about it. I think I covered it all.